Nintendo Switch. See if I can show you what is going on here. We clearly have a bit of a mess inside the port. Don't want to assume anything, but that looks like enough cross signaling that we probably or possibly could have some collateral damage, but you just never know until you get these things apart. So that's what we need to do. We need to disassemble entirely, pull the board, pull the port, and then do our testing for any possible collateral damage. And that's what we're going to do. Okay, we have the board out of the housing, and we are preparing to remove the port. But before I do, and while I set up my equipment, let me throw up my expected temperatures for this job. Disregard the 20% unless we end up having to do like a BGA or maybe a filter of some sort. In that case, I will probably drop it down to 20%, but that would be only if I do one of those two things. Okay, and for this we are going to do what we always do. We're going to flood everything we can see with low melt, the anchor points and the visible pins, and go from there. And we want to saturate these and get as much of this low melt to suck in as possible. Get our visible pins here. They're well saturated. Make sure that solder gets underneath them, the pins. Alright, let's bring the sauce and blow our port off this board. Nice clean pull. Alright, check and make sure we don't have any bridges, and I do not see any that would interfere with our readings. So let's connect our meter. Not that it makes much of a difference. We're doing continuity, so I'm just listening for the beep. We'll start our readings as usual around the M92T36. First capacitor we'll start with though is the capacitor that is connected through the M92T36 to the Pi 3 USB on the other side of the board, and the side we do not want to have a pathway to ground is the side going to the M92T36. And we do have a pathway to ground, so we clearly have a Pi 3 USB error. Alright, let's check the other caps and see if we have an M92 problem. I'm not surprised with all those pins touching. I don't feel like I'm getting a very good path. I'm not very good with my ground point, so I'm going to go up here on the ground test pad and test again. There we go. Now, anytime you have two lines going to a chip from a capacitor, one of those lines at the sides is going to be ground. Seems our CPU cap is fine. That is good. Check around our MOSFETs. Everything seems okay. Let's check our invincible fuse. Still being invincible. Check a little filter. Very good. Alright, now we're going to start testing our test pads. This one should be ground up here. That's usually why I was using it as my ground for testing everything. And now we're going to test these pads here. None of these should have a pathway to ground. If one of these has a pathway to ground, typically you're looking at an M92T36 error. That's been my experience so far. Alright, nothing around the BQ24193. Okay, everything looks good around there. And one more pad that should not be ground. That one should be ground. Sure, we're getting a good connection. If we weren't, so let's just test again, make sure everything's testing good. All right. So our coil is good. Sometimes it's a little hard to get through the manufactured residues, so don't be trolled by that. Alright, so we should have a Pi 3 USB issue here. That is the ground side, and that is shorted to ground, so Pi 3 USB is definitely bad. Let's check our filters. I am feeling like this one has a bad side. But again, you can be trolled by this manufacturer residue, so, but I don't think we're being trolled here. Yeah, we're not getting any continuity through that. So we also have a bad filter, bad Pi 3 USB, which we need to deal with. Let's go ahead and pull the chip and the filter. Alright, let's pull the chip. Alright, chip is pulled. Now we want to test to make sure that our short is gone. And it is not. That is not a good sign. That's very unfortunate, actually. I'm really surprised we're not getting a short on this capacitor. This one here. We are getting a reading. I am afraid we have lost this one. It is taken out our CPU. It's not beeping, but as you can see on the meter down below, we are getting a reading where we should not be. It is a pathway to ground. Unfortunately, RIP. So, sadly on this one, it is a very good demonstration of what can happen when you break your port and bend a bunch of pins together. All those signal lines touching, and end up putting power back through the system. All those lines touching, and they put power through it. Sent onrush current through that filter, through the Pi 3 USB, and straight to the CPU. And it is no more. There is no fixing this, unfortunately. So, RIP. It does happen, unfortunately. It's actually happened. That's the second time this week I've had a bad port turn into a dead switch. If you have any questions about the equipment I used in this video, take a look in the description below. If you like this video, do me a favor, hit the like button. And if you want to see more like it, hit the subscribe button, maybe the notification bell. And you'll know when I post videos, which is usually about twice a week. All those product descriptions in the description are Amazon affiliate links. So if you click on any of those links and make any purchase while you're in that session, it would help benefit the channel, and we'd be greatly appreciative of it. There's also some other support links if you want to take advantage of those. If not, don't feel obligated. Appreciate you watching, and we'll see you next time.